Okay, everybody, so today we're going to take a step back into something that you did in geometry. You may not quite remember it specifically, but that's the reason why we're going to review it real quick here. And that's special right triangles. Now we know that with right triangles, anytime that we're given one side looking to find another side or another angle, then we can always use SOHCAHTOA. Okay, but in the case of special right triangles, there's a few shortcuts we can use so that we can get to our answer a little bit quicker and we don't necessarily need to use SOHCAHTOA. Now the two different special right triangles you're going to see are a 30-60-90 and a 45-45-90. And each of these show up specifically when we use the unit circle quite a bit. So we're going to refresh this today so that when we talk about the unit circle, we'll be ready with our special right triangles to help us find things. Now, first of all, you have to be able to identify in a 30-60-90 what side is the shortest, what side is the middle length, and what side is the longest. Now, we know that the hypotenuse is always the longest. Okay, and the hypotenuse is always opposite of the 90-degree angle. The shortest side is always opposite the smallest angle. In this case, 30 degrees is the smallest angle. So the shortest side is going to be across from the 30, and that leaves the middle length side to be across from the 60. And that's important to note as we go through these, okay? I'm going to just kind of undo those things that I just wrote there. Whoops. Where am I at here? Oh, there we go. Let me just throw the eraser in here. Okay, so I'm across from the 90-degree angle for my hypotenuse, and I'm across from the 30-degree angle for my shortest side. Now, here's the template that we are going to use. When you have a 30-60-90, the shortest side, we're going to call that side N. Okay? And the reason we're just giving it a variable is because we don't want to specifically talk about a number right now. We want to talk about what happens to that number to find the other sides. If I have the shortest side, then my middle length side is going to be whatever that shortest side was times the square root of 2. And my longest side is going to be whatever that shortest side was times 2. And I got to go back here for a second because it's not square root of 2, it's square root of 3. Sorry about that. So my longest side is going to be the shortest side times 2. My middle side is going to be the shortest side times radical 3. Now what about if I have a 45-45-90? Well, the good news is that I know if those two angles are the same, then this is an isosceles triangle, so those two sides are the same. So if I'm looking at a template for this, my shortest sides are going to be the exact same, and my hypotenuse is going to be whatever that shortest side is times the square root of 2. There's my square root of 2. So these are the two templates we are going to use as we solve some of these. So let's put them to work. Here I have a 30-60-90. All right, I know that if one angle's 90, the other one's 30, the third angle has to be 60 degrees. So I'm going to start by putting my template next to this. So I'm just going to write in my template. I know that the shortest side is always across from the 30. I know that my hypotenuse is always 2 times my shortest side. And I know that my middle side is always my shortest side times the square root of 3. Okay, so what am I going to do if I'm given this side and I want to find the shortest side? Well, to get from this side to my shortest side, I essentially need to take my middle length side and divide it by radical 3. Because when I take a n radical 3 divided by radical 3, it leaves me with n. So over here, if I want to find that shortest side, all I simply have to do is 1 divided by radical 3. Now we talked about the fact that we cannot have a radical in the denominator. So although, yeah, this side right here is 1 divided by radical 3, that's not in a simplified form, so we have to simplify it. So to get rid of that radical 3 in the denominator, I'm going to multiply by radical 3 over radical 3. I know that radical 3 times radical 3 is just 3. My numerator just becomes 1 times radical 3, or just radical 3. So let's write that on this side in my simplified form. Okay, this side is radical 3 over 3. Okay, so I have found my shortest side being given the middle length side. So what if I wanted to go ahead and then find this side? Well, to go from my shortest side to my longest side, all I'm doing is multiplying by 2. Okay, so it's like taking this and multiplying by 2. 2 over 1. The denominator is still going to be 3, and the numerator I just do 1 times 2. So this side here is 2 radical 3 over 3. And I have found all 3 sides being given the middle length side. Now that's going to be pretty much the hardest one, because what if I'm given one where now they give me the shortest side? Well, if this is 60, that means this has to be 30, and my shortest side is here. My longest side is 2n, my middle length side is n radical 3. Why do I keep wanting to do that? N radical 3. So, in this case, if I'm given my shortest side, that's a good thing. Because then to get this side, all I have to do is take my shortest side and multiply by radical 3. Well, 1 times radical 3 is just radical 3. And to go from my shortest side to my longest side, I'm just multiplying by 2. 1 times 2 is 2. And I'm done. So you can see how that can be a lot faster than doing SOHCAHTOA. Okay. How about 45, 45, 90s? Well, if I draw my template next to this, I know that with a 45, 45, 90, the shortest 2 sides are the same. So I can go ahead and put 1 there. And then my hypotenuse is n radical 2. So to get from a short side to my longest side, I'm going to multiply by radical 2. So to get from 1 over to here, this is just 1 radical 2, which is just radical 2. Done. And considering I'm going to stay in exact form, then I think it's important that we don't necessarily go to SOHCAHTOA, because SOHCAHTOA is going to give us decimals, and I don't want decimals. Okay. And then the last one here, so 45, 45, 90. Shortest 2 sides are always the same. This has to be 1. To get from my shortest side to my hypotenuse, well, I know my hypotenuse is n radical 2, so I'm going to multiply by radical 2. To get from here to here, just multiplying by radical 2, it's just going to leave me with radical 2. Special right triangles.